Good afternoon, ladies and gentlemen. I promise Marie-Claude and I did not actually coordinate our outfits, but it worked out quite well in the end. Yeah, fantastic. Well, thank you for being with us here today. We've got a fantastic panel set for you today. We're going to be talking about quantum in practice, lessons from the field, and we have what I think is probably the most varied panel of the conference so far, because we've got people from all over the place. We've got Bank of Canada, OTI Lumionics, we've got people from PINQ, and people from Honeywell. Yes, fantastic. Yep. So we've got people that cut across both people working with quantum computing and other emerging technologies in practice. In industry, we've got people who are the go-betweens between potential customers and technologists and academics. We've got people from all over the show, and I'm looking forward to hearing some of the perspectives people bring to the panel. So before anything else, I'll introduce myself, and then we can go through everybody one by one as well to hear a little bit more about themselves in their own words. But yes, I'm Dylan Barry. I spend half my time writing for The Economist. I write on physics, neuroscience, genetics, and AI. And in the other half of my time, this year in particular, I'm the executive director of the von Neumann Commission, which is an independent research commission looking at the prospects for quantum computing to act as an accelerator for machine learning and artificial intelligence, and trying to work out what that means for policymakers. So yeah, I'll hand it over to Marie-Claude to tell us a little bit about herself.
Thank you. I won't speak as fast as him. English is my second language. In French, maybe I would, but in English, I'll be a bit slower. I'm Marie-Claude Messier, General Manager of PINQ, and I'm an engineer. I'm not a quantum expert, but I'm a business expert, a take-to-market expert. This is what I do, especially for advanced technology. I did it for e-commerce. That gives a bit of an idea of my age. I did it for e-health, for cloud, AI, and now I'm so excited to have the opportunity. My mission is to take to market quantum technology, especially quantum computing. I'm General Manager of PINQ since a few months and looking forward to talk a bit more about how we can take quantum computing to market in Canada.
Thank you. So Andrew Csizmar, I'm a senior director at Honeywell. I take care of kind of the global space strategy. So within this is actually connecting the globe from a quantum network perspective, but it gets past that in terms of how do we connect ships, aircrafts, ground-based systems, as well as what does that look like for LiDAR applications. Within Honeywell, it's a little bit unique that we play in all three kind of pillars within quantum. So we're really trying to solve how do we actually get that distribution. But a lot of the technology is actually led within Canada on how we do that, and really about connecting the globe and enabling this kind of race of what does this global quantum future looks like.
My name is Genin. I'm the Vice President of Materials Discovery at OTI Lumionics, where I focus on the preliminary R&D for material design, from simulation to preliminary synthesis. And so, we're a very big consumer of material simulation software and tools. And so, we had the opportunity to join CDL back in its inaugural quantum year in 2017. And we've been on this journey of developing, quantum algorithms across predominantly almost exclusively focusing on material simulations. However, even through our own journey, we basically have not only run on pretty much almost every type of architecture, but, we develop our own internal emulators, predominantly focusing only on material simulations, but we're more than happy to talk about those actual experiences of scaling up simulators that can run up to 300 qubits, et cetera.
Okay, hello everyone. Good afternoon. My name is Maryam Haghighi, and I'm the Director of Enterprise Data Science and Insights at the Bank of Canada. That is the Central Bank of Canada, and our teams are responsible for the various aspects of emerging technologies when it comes to the work of central bank. So that would be a range from AI to quantum computing to also our platforms responsible for delivering analysis that is the backbone of the work that we do as a central bank. My focus lately has been mostly around our strategic perspective in this regard. And on that note, I would share two things with you. First one is a legal disclaimer. I'm here to speak about my own views, and my views do not necessarily represent the views of the Bank of Canada or the Governing Council of the Bank of Canada. And the second one is my promise to you is that you will walk away from this knowing why a central bank should think about quantum technologies.
Fantastic. So we've got a fantastic mix of people here. I'll jump first to Marie-Claude to tell us a little bit about what specifically PINQ does in and around quantum technologies and the role you play interfacing between industry clients and people working, companies themselves and people working in academia.
Absolutely, and I'm looking forward to be able to collaborate with the Bank of Canada for sure. So PINQ is a platform that integrates classic and quantum computing with an interface to allow the users to have an easy experience at using both technology, classic and quantum, where our mission is to help the enterprises with the universities, the researchers, the academy, to increase their competency, develop their competency in order to be ready when quantum will be commercially viable. So how do we do that? We work with the ecosystems in Canada. So there are many provinces already embarked into quantum technology. For sure, Quebec, with the University of Sherbrooke, the ICI QUANTIQUE. In fact, this is where we come from. We are kind of a spin-off from University of Sherbrooke. So we do have a quantum computer today. We do have the IBM system, QS1, that is installed here in Canada, in Quebec, in Bromont. It's 127 qubit, and we're upgrading it to a 156 qubit as we speak. It's being upgraded right now. We do also have classic computers, and that allows the enterprises to work with the researchers, the startup, to identify in advance the use cases that will be relevant for them, to work with the researchers, the scientists, to develop the algorithms in order to be ready when quantum will be commercially viable. Be ready is, at minimum, identify what are those use cases that will allow us to be better than our competitors. So finance is one of the verticals that is extremely relevant for us. Quantum computing will be relevant for most of the industry. We've chosen to start with the top three. For us, finance, aerospace, defense, we're allowed to say it now. So aerospace and defense, and environment and energy are the three verticals that we're developing in Quebec and the rest of Canada. So this is what we do.
Fantastic. Andrew, do you want to tell us a little bit? You mentioned earlier that Honeywell has kind of thumbs in all of the various quantum pies of sensing, computing, and communications. Do you want to give us a little bit more detail about the actual work you're doing, some of the fantastic space-related stuff you're doing as well in that area, and maybe clarify for the audience the relationship between Honeywell and Quantinuum, which is a quantum computing company they might have heard of.
For sure. So I'll start with the quantum computing one first. So Quantinuum is a separate entity, but it's still a joint venture with Honeywell having a majority share ownership within that. However, we build all the hardware. So all the trapped ions come within an internal Honeywell foundry that we actually build. So having the ability to do an actual very low loss in terms of integrated photonics is a key kind of technology building blocks that then Quantinuum leverages, packages, and then delivers that to an end-to-end quantum computer. So we're very much tied back into the foundation of what is the technology and how do you actually manufacture this, and then how do you scale that. As it relates to quantum communications, this is where we do a lot of work in terms of how do we expand the global kind of connection parts. So we're actually building satellites to do ground-based to satellite-based kind of distributions. We're working with the Canadian Space Agency in this area to actually deliver a mission that's called KeySat, and we're the mission prime doing the full spacecraft launch, deployment, and operations before that kind of goes to the Canadian Space Agency. And then more recently, we've taken over a European Space Agency, which is called QKDSat, heavily funded by the UK government, which is going to be a first commercial end-to-end service that Honeywell will deploy in terms of how do you do distributions around the globe. When you start taking a look at this, it's about quantum networks. So step one is how do you create a quantum safe network? But then when we're really starting to ready do entanglement distributions. We have a couple missions that we're doing entanglement distributions both on the ground, but entanglement distributions within space as well for more military applications in terms of what you can do there. And then on the sensing side, we're a very large like aviation company and the actual guidance that controls. So the majority of the market, I would say close to 60–80% of the global market for aircrafts or landers or launchers are actually coming from Honeywell products. So we actually see the quantum sensing as a threat to our core market. So we're spending a lot of time on new innovations that are going to be there. When are they ready to be adopted? When are they going to be integrated? And what are the actual areas now that are ready, and which ones we think maybe in 5 years, 6 years time that they could actually disrupt our core kind of market. So I'd say in all these areas, it is very much a global kind of team that we have on that side, but it also allows us to kind of leverage a lot of the capability within Canada. It's amazing on how much of that technology is already being leveraged in around the globe and how we can kind of export this and create these opportunities.
Fantastic. And Scott, you already explained a little bit in your introduction the kind of work that OTI Lumionics does with quantum-inspired and quantum simulation. Could you talk a little bit about what is possible now, what is possible in practice now for a company like OTI Lumionics, and how you're thinking about the possibilities going into the future?
Yeah, so kind of what is possible now, at least with quantum computing, is well, it really depends on what your application and your use case is. So the only one that I can speak to in excruciating depth to, but we'd run out of time, is the kind of on the material simulation. So we do very much focus on, basically, can we reach benchmarks of various material simulations? In kind of current terms, we can simulate almost a wide range of organic molecules, ranging up to like 200 to 300 atoms. Quite reliably, but that's because we spent, so many years of development of our own internal simulator when we basically strip out the requirements that other simulators that use like state vector approaches need to simulate quantum noise. When we basically strip those features out and say we don't want any noise, we just want the answer, you can actually scale these things very, very rapidly. The inherent challenge is that still, don't get me wrong, this is not something that happens overnight. These are, multi-year journeys. But in my opinion, is that this is very worthwhile from our perspective, is because in material simulation, the very generalized software is almost all open source. Like any one of you today could go and do electronic structure calculations, download PySCF or Sci4. You can do it right now. But if you wanted something that was like far more specialty that could do, scale at, across multiple GPUs or be used for HPC, those are, faster it goes, the higher the cost. And in our industry, we can get basically, well, from a customer, we need this changed on the material. You have 2 weeks to do it. Otherwise, you're going to miss mass production deadline, or you're going to miss the window to go into mass production, if you can't fix it within 2 weeks. And so this kind of speed is incredibly important, especially when we're talking about trying to get completely new materials into mass production. That's one of the areas why we invest so much time in developing very high accuracy simulation tools internally. And we think that the quantum inspired methods have basically enabled us to reach these performance metrics that are kind of unmatched. But there's still a lot more opportunity to still be explored, right? And I think that there's been a lot of exciting development, particularly with the surface code and error corrections that have come online. 3 years ago, I never thought that we'd ever see quantum phase estimation actually run, yet Quantinuum did do a result. And while there's still a lot more work to go on that exact result, it's impressive that a company actually executed the quantum phase estimation algorithm for a molecule, right? But my opinion is that if you're not already investing in learning, understanding, and developing solutions for your own company, you end up going to having to, I'd recommend that you start partnering with other companies or start developing it internally, because otherwise, like 5 years from now, when these things become actually usable, you're going to end up paying a lot more than if you actually invested now.
Fantastic. Now, Maryam, you occupy a very interesting position here. You raised the question, why should a central bank care about quantum computing? I'm going to ask you to tell us why, and tell us a little bit about what the Bank of Canada is actually doing practically in terms of quantum technologies and quantum computing.
Excellent question, Dylan. So before I get to that, I want to share something with the audience here. So, you know, we've been here for almost 2 days now, some of you 3 days, and you've been hearing all these fantastic presentations, panels, you know, the exhibition, etc., all really good. I was reflecting last night when I went back to my hotel room, and I was thinking, you know, really the nature around us is quantum. For decades, we have forced it into this digital 0-1 narrative of abstraction. It's really that 0-1 abstraction of the digitalization, it's a purely human construct of the nature around us. And we've tried to simplify this to zeros and ones, and it's worked out really well. We are here, we are transmitting, we have the internet, we have mobile phones, etc. But that still is an abstraction of reality, and perhaps, just perhaps now is the time for us to shift our mindset, to go back to the origin, to the reality, and remove the 0-1 abstraction, and start considering problems in our businesses, in the world around us, within the context of quantum science, quantum technologies, quantum sensing, quantum computing, etc. And I know it's like a mindset shift, and I know it's a philosophical shift, and it's not something that comes easily because we go to school and we get trained to think about those digital forms and zeros and ones and algorithms and steps and so on and so forth. But now we have the technology to shift back, and I think the humanity will be better off in some decades in the future by thinking and changing the philosophy of how we fundamentally view the nature around us. And yes, this has been in the making for many years. In fact, I remember the first time I heard the word quantum computing. I distinctly remember it. It was fall of 1994. It was November 1994, in fact, I remember that. And I was at an academic conference, and you know, like a university conference, nothing fun like this. One of those with really bad stale cookies. So here the food is much better. But the news broke out about Shor's algorithm, and the talk of the room was about that. But then everyone said, oh, well, we don't have that. That's all hypothetical. We don't have the technology now. Here we are 30 years later, and we are exceedingly close to, we already have the technology in place in some aspects, in quantum sensing and in quantum communication. And in a broader sense, we are getting closer to having that even more and more available. So to your question of how does this relate to our work in central banks? So first and foremost is data security. For securing our own system, that in a way is no different than any other agency or any other department, okay? So we have that upon us. We do that currently, and we're going to continue doing that. But also, we have a role to play in terms of the security of the financial system. And people often refer to central banks as benchmark players, okay? And that's because the steps we take signal an approach that needs to be taken within the financial system for all banks globally, all central banks, but also all commercial banks, to up the security of their system. And that is to the benefit of everybody. It's for the public good to up the security of the system, whether it be for the threat of harvest now, decrypt later, which already exists, or be it for the future threat of quantum computing, whenever that they may be. And we look at this from a macro level, from a financial stability angle as well, when we talk about the problem of data security. Now you can flip that lens of data security and you can think of digital privacy of citizens in that lens as well. And then you see the connection there. You could also look in terms of saying, okay, if we want to leverage quantum computing machines, what are some of the concerns? And something that's interesting, and it's still in research phases, but blind quantum computing, as an example, these are technologies that are being developed which all fall under that broad umbrella of security. And lots of great work has been done by the companies that are here, by the people who were on this stage, Michele, Bruno, others. Many of you have done such tremendous work in this regard, and the work continues. So that's one angle that connects to us. The second one is around that integration of quantum technologies and finance. So financial products that are made, as an example, and financial systems that you all use, payment system being one key example of that. Those are broad systems and products that can benefit from quantum advances. And we have already started doing some proof of concept work in that regard. In fact, this work started in 2018, 2019. It's nothing new for us as a central bank. And our partners globally with the G7, all central banks, they have also started looking into this. We have a G7 Quantum Technologies group formed that Canada is the chair, and I have the privilege of seeing the interaction of the central banks, the G7 central banks in that group, being its chair. And what we see is the interest in this regard, and the early proof of concept are demonstrating the potential payoff. So I give you a concrete example. In Canada, we have a payment gross settlement system. It's similar to other G7 countries, some variation, some technical variation, but essentially it is the system that all of us use. When you go to a merchant and you pay with your debit card or your credit card, you bank with bank A, the merchant banks with bank B. Somehow, your money from your account from bank A needs to get transferred to bank B. And these millions of transactions happen every day. So there is a settlement system for all of this. That's why it's called gross settlement system. And central banks are the key brokers, key distributors in that system. We tested a quantum optimization algorithm, and that was something that, again, yesterday was discussed about quantum optimization on finance, so that's why I picked this example. We tested the quantum optimization algorithm within the context of this system. So we took 1 month's worth of real data from Canadian gross settlement system, so historical data, but real data. This was not, fictitious. And we designed the optimizer that's right there now. There is a classical optimizer, and we replaced that with a quantum optimizer, okay? We won't go through the details. I can't. If you're interested to know about the details, I'll hook you up to my team who did really smart work on this. But that's essentially changing that brain, that engine of the settlement system with a quantum optimizer, and run it again to see how the quantum optimizer performs in comparison to the classical optimizer. And again, this was real data that we have that we can do this comparison. And people think about quantum and say, oh, it'll be faster. One of my pet peeves, this is not about being faster, okay? It's about being better. I'm going to use an analogy that yesterday, I don't know if he's in the crowd still or not, Kevin gave this analogy, and I told him I'll steal the analogy. It's like 2 hockey players that both can skate at the same speed, but one hockey player can score more goals, can score better than the other one. But both of them are speeding very fast. So these classical and quantum optimizers, it's not about quantum one being faster, it's just that it scores better, Okay, so what does that translate to? That translates to an average of $240 million Canadian in liquidity saving per day on average, and in some days hitting a threshold of $1 billion Canadian in that proof of concept, okay? So it's a demonstration of proof of value, proof of concept, and you actually have tangible numbers attached to it coming from real data. Now, of course, that gets everyone excited and say, well, can we implement that? And that these are, you know, large sums of money that our society can benefit from that. The answer is perhaps someday. We are not there yet. A lot needs to be done by the industry to make these systems and these algorithms to a level that can be operationally ready, to a level that would meet our resiliency requirement. But as a proof of concept, the value is there, okay? So that's something that shows how work of quantum technologies can relate to the work of central banks.
Fantastic. Well, we've had a fantastic cross-section of quantum in practice today across a variety of fields. Why don't we move into the sort of lessons learned? I'm sure all of you put effort into this, you put resources into this, you put a lot of thought into trying to find advantages in quantum technologies in your particular fields. Inevitably, there will have been things that worked well and things that didn't work perhaps as well as you might have thought going into it. If you had to start again from scratch 5 years ago or 10 years ago, whenever your company started moving into this direction, what would you do the same? What would you do differently? What were the surprises? What worked better than expected and what worked a lot worse than expected? And I'll let Marie-Claude take it first.
Absolutely, and thank you for sharing the information, because this is a great segue for what I will say here. What worked very well is the development, the implementation of the infrastructure. So implementing the infrastructure, developing the platform, the software to access, all this worked quite well as planned. What did not work as well was the enterprise adoption. Didn't work as well as fast. We were selling access to classic and quantum computer without the right interface, and also more so without the right consulting. So finding the right use case for the enterprises, it's not that simple. We need to help them get there. So what we've done at PINQ is we are not selling access to these computers only anymore. We've developed consulting arms, consulting approach that will allow us to work with enterprises like yours in order to help them identify what are the most relevant use cases based on the practice in the industry, but also based on their usage, their needs. And once this is done, then we match them with the most relevant scientists that have the right competency, that are available in the Canadian ecosystem. For sure, universities, researchers from universities, this is where most of the scientists are to develop the algorithms that will be from those use cases, but also from startups. So there's a lot of great startups. We've heard a lot of these startups throughout the last few days. So this is what we do. We help the enterprises identify the right use cases for them, and we match them with the most relevant scientists available. What we do also is we help them develop their quantum journey. What is their strategy to get ready, to be ready when quantum will be commercially available? So is quantum in your strategic plan? 90+% of the time, the answer is no. It must be in your strategic plan because it's coming the next few years. A strat plan generally is 5 years, so quantum must be in your strategic plan, and we're helping the enterprises develop their quantum journey. So that's what we learned, and that's how we evolved.
Fantastic. I'll toss it to Andrew.
Sure. So I would say we're a technology company, so quantum was just a natural progression. What we were looking for was where are the applications. For us, what worked well is we're very tied into all these different industries and very tied into either products that we have classically that we can't solve a certain problem set, and we're actually introducing that to actual customer bases where they're actually adopting and actually see the value of what quantum can bring them from what we're already delivering into solutions. Within there, that's what really evolves into all the segmentations, and we're always road mapping this out. So early investments, fundamental key to actually get those technologies, get the adoption, get the actual applications that move forward. The real difficulty is how do you actually implement this at scale, and that is actually used within both military deployable systems that it must work. Because there's one thing in having a technology in the lab, there's another thing when it's an operational technology that must work. And how do you actually deploy it at the scale that's required to get the adoption? Because if we have corner cases that these can be used in, the adoption's not there because they still need the reliance, globally in terms of what they're looking at, both from a commercial operations perspective or military, both the dual use kind of applications. So that scalability, it was foundationally, difficult. And that's, even for a large company like Honeywell, that is what we're focusing on, is how do you scale these solutions? How do you take them to industry? How do you actually operationalize these so that the adoption and the actual use cases, they're there, but they need to always work, not work sometimes and just in the lab. So that industrial hard kind of application or scalability, that's the real challenge that we see, and that's what we're trying to focus it on, of how do we actually grow this and actually take that to customer bases.
Fantastic. Scott, I'm going to hand it to you, and I think you have a particularly interesting perspective because unlike PINQ and Honeywell, who are in a sense selling the shovels, they're selling the tools that are used for this. You're on the sort of consumption end of using these tools in a kind of different industry. What are the lessons that you've learned about what's worked well, kind of playing around with quantum and quantum-inspired technologies? What would you do differently if you could start from scratch today? And what advice might you have for companies in a similar position?
Well, 5 years ago, I sure wish I knew what I know now. There would be a lot less projects that we'd have to can midway through. But it is like, a lot of it is even in terms of developing an implementation, there's a lot of things that you'll try that will just not end up working, and it's it comes down to a judgment call of how fast can you actually can a certain project, or how fast can you pivot from one to the other. I think one of the things that we at OTI did very well is that we were able to, we would never blame any of our scientists for any project that just could not progress, right? There are just some approaches that, in the current state, whether on an emulator, whether on an actual hardware, they just don't work at this current point in time. And it was just important to be able to cycle through those projects very quickly and actually continue to focus on what works and really emphasize and push through to make all the pieces, in the software and actually end application come together.
Fantastic. And Maryam, you also have a very interesting perspective on this. From the perspective of the Bank of Canada, what has worked, what hasn't worked as well as you might have hoped, and what advice would you give other institutions in a similar?
So I think three things. One is reiterating the importance of partnerships. And we have had joint projects, but also just general discussions and engagements with startups. Many of whom you heard the names here, Xanadu, Multiverse, EvolutionQ, Crypto4A, but also larger companies, large players like IBM, like Microsoft, like Honeywell, et cetera. So all of these engagements, we learn. And by we, I mean both parties. We learn about quantum technologies because these companies have the expertise on that side, and they learn about our business. And I think that's kind of where the magic happens, because you need that translation of business problems into technology solutions, and that's not easy. And that connects to what you were saying about operationalizing and scalability, because ultimately that's what we need to achieve to be able to gain economic benefits. Which then brings me to the second point around supply chains and connection to talent. And fostering that environment, that ecosystem of talent, being from co-op students to business experts who know about quantum, generally speaking, to deep technical PhD level expertise on physics or other areas. So the whole range is required. It's not just one avenue, and you need to build that out over the years, and it takes time. This is why I mentioned we started in 2018, 2019. In fact, in 2022, we developed our quantum strategy for the Bank of Canada, and we were the first G7 central bank who developed that strategy. And that strategy emphasized all the points that I said. First and foremost, what we've learned, data security. That is the top question. That is the top angle for us to look into. That has connection with quantum algorithms, computing, communication, the whole range. So that data security question is the top reason. And then everything else that I mentioned around it was in terms of learning with that engagements and joint partnerships. So that would be, I would say, a way to summarize our lessons learned. The other one is my personal reflection of where we are at this point globally and where we are at in Canada. And it's fantastic to see such support around this momentum that we have today. You even heard from the minister this morning when he shared his message about where Canada is at and how that will get supported for Canadian ecosystem and Canadian talent to build partnerships, but also to really benefit from that within Canada. And I think that brings a question around prioritization, because we don't have unlimited resources, we don't have unlimited dollars, we don't have unlimited talent. So how do you select key use cases, key angles where you invest your time and your resources and your talent into those to really develop world-class expertise? I mean, we already have world-class research, but turn that to world-class products, world-class operationalized systems in some key verticals within this large range of options available. Sometimes I wonder, we want to be, it's like a parent and you want to be nice to all of your kids, and so you kind of barely go around and you help out everybody, which is nice, but is that the most strategic angle to take? Should we think really strategically and prioritize and say, as a nation in Canada, where are those spots where we can be key players and do those for the economic benefit of our own nation, and to provide those technologies to our like-minded allies, because we are the absolute experts in those verticals. And I'm not saying that necessarily has to be finance. It could be material sciences, or it could be something else, or data security, whatever. But we have to really think strategically about selecting the next move. Going back to that analogy that was said in one of the panels earlier today around surfing the wave, right? So you want to pick that right timing, but also the right wave, not the wave that just dies out, okay?
Fantastic. So we've got about 5 minutes left. I've got 1 or 2 questions here that I'll jump to in a moment. But before I do, I'll just remind the audience, if there are any burning questions you have for our fantastic panel over here, feel free to send them through to Slido, and we may be able to squeeze them in before the end of the session. Inadvertently, we've already actually answered 1 or 2 of the questions that have been asked, but one of them actually pivots quite nicely off of what Maryam has been saying, which is from Anonymous. How do you approach upskilling within your organization or among your partners, given that quantum is a complex domain? Now, Maryam spoke a little bit about that already, but I'll toss that broadly to the panel as a whole if anybody has any thoughts on how you have perhaps already approached that within your own organization and how you might advise approaching that for other institutions or organizations moving down this path.
Well, if I may start, you must start now, get your hands on the keyboard in order to learn what it is and how different it is. Once you started with 1, 2, 3 use cases, then you can make sure that you have the right experience, the right knowledge in order to be able to develop your strategy and then grow over time to be ready when quantum will be commercially viable. So start now and practice and understand how different, how complex quantum computing is and how it can propulse your organization elsewhere.
Yeah, I would say I'll take like the business side of it maybe a little bit more is, every business runs on the finances and the return on the investments. Pick the areas that actually resonate for the business and the adoption will get a lot easier because there is always use cases. Is it actual generation in terms of revenue and sales in terms of products so that you're looking at, or actually adoption of how you can actually be more efficient within the business. It doesn't have to be a cast across the overall business, but in the end of the day, we operate, we succeed because we make money. And that's where those applications need to be very succinct, and that's where when you have that actually gets the adoption, and then it starts to grow from there. And that's, I would say internally, it started small, but it's seen across as ways we protect the business, the way we grow the business, and ways strategically it's going to drive the future for us.
Scott, any thoughts?
I think I'll keep mine fairly short, but my advice is if you really need to scale up this stuff, go and try to find the cheapest source of HPC performance, because whenever you want to use a quantum computer, you still have to interact with it through a classical computer, and some of the upfront work still has to be done classically, and sometimes you need just a lot of resources, and some cloud offerings would bankrupt a company very quickly. So if that's through a university or through you building your own HPC cluster, get the cheapest source of high performance compute you can.
Fantastic. And Maryam, you already spoke a little bit about the upskilling in the lead up to before I asked this question, but if you have any additional thoughts, feel free to toss them in at the end.
No, I don't want to get blamed for plagiarism by Nike, but just do it. just start somewhere, anywhere, really. Start somewhere. And you can use all these lessons that were shared today, but just start somewhere.
Fantastic. I think as well, just from, I've had a few conversations about this, both at this conference and prior events of a similar nature, but I think there's two things. In the short run, there is going to be a need for upskilling, but sooner rather than later, quantum will just be part of the hardware stack, and there will be enough abstraction between sort of the real quantum stuff going on under the hood and the applications and APIs that at a sort of industry level and consumer level that you have access to, that you probably aren't going to need to know what a superposition is or how to entangle your qubits to work with these tools. We're not there yet. There's a lot of people working on those kind of upper layers of the software stack, but in the short run, upskilling matters, but in the long run, hopefully it won't matter quite as much. Fantastic. Well, I'm mindful we haven't had any more particular questions that we haven't already answered, I don't think. If anybody wants to pop one in the next 30 seconds or so, they're welcome to. But otherwise, we might just wrap this up slightly early. So thank you very much, our wonderful panelists. Thank you very much to the crowd for giving us your time. Give them a round of applause.
Thank you.
Thank you.
Thank you.